Hi, my name is Borem. In this lesson, we're going to talk about what legacy code is and how we write tests for legacy code. When we talk about legacy code, in general, we mean code that it is difficult to work with. It can be code that it is written using old techniques, code that it is no longer supported anymore, or even code that it is new but have no tests. When we think of new code that it is written without tests, we always know that it's always difficult to make changes and being sure that we don't introduce any new bugs, which leads to the first point again, code that is difficult to work with. That's why when we write code, it is always good to have automated tests around our code, so that we be sure next time we go and refactor or we change something that we don't introduce any new bugs. When I write tests for legacy code, I always do it in 3 different steps. First step is pin down the current behavior by writing tests for the current implementation without changing anything into the current implementation. When I do that, then I'm sure that my tests will save me, most of the times of course, if I have good tests, for not introducing any new bugs into system. Then I go ahead and refactor the code so that I can write unit tests around it. And when all of my tests are green again, I know that my refactored code worked as it was before I refactored it. This is a bit reverse engineering, since tests should be written first, but I think it is better to write tests for your code than not have any test at all. When I'm done with the first step, then I go ahead and change tests or test cases or write a new one that matches my new requirements. Tests should become now red since my test expects different implementation now. Then I go ahead and make changes to my current implementation so that all tests passes and become green again. Let's imagine that we just received a change request for a service that is responsible for order shipment. Same service now is going to send email confirmation to our client as well. We know that our current implementation has been online for 5 years now and it has been working just fine. Now that we need to make changes, we have to be careful what we can change and how we change it. The change means that we are going to add another call so that goes to another provider outside of our network for sending email confirmation with order details. Any change on our current implementation is risky since we do not have any tests. I have chosen DB implementation, WCF client, and Web API call. On our current implementation, none of those is mockable, and we do not have any tests. I have chosen WCF since WCF client is a bit hard to mock, and I will show you why and how I mock it. Now I'm going to apply my 3 steps technique for adding tests around it. There will be a link that goes to a repo on GitHub so that you can compare the implementation before and after. I am going to use Visual Studio 2017. The code will be on GitHub as I described it earlier on my previous slide. During the time I write code, I will fast forward it so that I walk you through code instead. I will get back to you as soon as I set up the solution. Now that I have created 2 projects, I have the order service, which is an MVC project, and it's used by our internal staff for ordering shipments. This is just a simulation, so the user interface is pretty ugly. I have created the WCF service as well, that is hosted on by our shipment provider. And when we call the shipment provider from our order service, we will get back an ID that we're going to save into database for future use. this is the database. It is empty now. So I'm gonna go ahead and simulate a call from our order service. So let's say that we want to send something from Sweden to United States this hour. This is hour where I can be home so that the shipment service can pick it up. Now I create one shipment service client instance within the method, create the DB context. The connection string is hard coded since this is a simulation of the action, so I think having this way is not a problem. This is the ID. This is where we send data to our shipment provider for picking up something. We got an ID for our order, and then we save now into database. So if we go back to database, it should be, yes, this is it. And we show that ID to our user. I have used the data contract as view model just to show you that this can be used like this, or I have seen it being used like this in a project that I was involved before. So this is pretty much what legacy can look like. This is bad, doing this is bad, but right after I'm done with pinning down the current implementation, I'm gonna start refactoring it, and I'm gonna have a real view model so that we can use it right way. Now I'm gonna go ahead and create test project so that I can write tests for the current implementation as much as possible, so that I can cover it as much as possible. I'm going to fast forward that part and get back to you right after I'm done with it. I am now done with the first step, with the first test, sorry. At the setup of the test, I clear the order table. This has to go to a test database, but for now I just use the same. I create order shipment contract, call the subject on the test, which is the home controller, place an order, check the database that the order has been set so that it is only one order there, and I look at the order shipment ID is not equal to empty grid. I look at the data contract is the same as the address from and to, and I make sure that the saved order ID is not 0, so which means that this has been saved to database. This is kind of like a double check, since this makes sure the same thing here, but this can be written like this as well. Now if we go ahead and look at the current implementation, since both of these classes are created within the method, I can move those as dependencies to a constructor, and then inject fake or inject mock classes, and then write unit tests for this method so that I can mock all dependencies. I'm going to do that part. I'm going to try to refactor this one now, and I'm going to get back to you right after I'm done with it. I have now moved the dependencies to the constructor. So when I create home controller, I need shipment service client and iLegacyDB context. LegacyDB context is now implemented by the LegacyDB context here, but since the LegacyDB context inherits from the DB context, those two methods already are implemented here. So I just pulled them up using an interface here. The way you can do this, the way you can plan a unit of work around Entity Framework, there is another video that I have uploaded for a while ago now, and you can see there how I plan the unit of work around Entity Framework. For now, I'm just gonna go ahead and have it as it is, a very simple implementation, but I think it will do the job for us. So before I create this subject under test, which is the home controller, I create the DB context and then create a new shipment service client, and then send those instances for when I create the home controller. The reason that I use class here is that the interface that we get when we generate code from when the code is generated from our client, WCF client, is that the interface doesn't have those methods defined. So the definition of those methods isn't within the interface. So it's only if we want to use those, that is only a class that has those implemented. That's why sometimes WCF might be hard to mock. I'm gonna show you how I do it, and then get back to you right after I'm done with it. Now I'm gonna go ahead and write unit tests using unit of work and Fake It Easy for faking objects. I'll get back to you right after I'm done with it. I have written the unit test now, and the code is refactored. I'm going to show you what I've done until now. I have wrapped the WCF client within one class here using this class. This is how I wrapped the WCF client and pulled up those three methods that we need when we write, when we check for state, when we close it, and when we abort the client. So those three now I use interface here, and interface for the DB context, and the interface for converting data as well. So I can easily write unit tests and test only this class now. So everything else can be mocked. So since we have all of those are interfaces now. So when we receive the place order, now I have converted to a view model. I convert the view model to a data contract, make a request to our shipment provider, receive a shipment ID, convert it to an order, save that order to database, save all changes, and then view the shipment ID for our user. In final block, I dispose the data context and close the service client. If for some reason an exception occur when we try to send the request to our shipment provider, it will check if the state of the service is in fault, then you need to call abort. This is how you close the connection for WCF properly. Otherwise, it can be open. So I have written tests for both when it succeeds and when it fails. Unit tests. I use nCrunch for running tests automatically. It's something that I love because all of the tests are running as soon as you change the method or the implementation that you work in, and then you can see live where you can where you need to fix. So let's go to the tests, and I'll show you the tests that I have written now. So the succeed one and the one that throws exception. When we set up, this is how I set up the test case, and if the test case throws exception, this is when it says that it is in false state and it throws exception. I'll make sure that the shipment service has happened, abort, and dispose the data context has happened, and the service client has happened. So this makes sure that I have closed the client properly and disposed the DB context. When it succeeds, I have the DB context, the save changes, and this must happen once. I'll make sure that I'll dispose the DB context and close the connection. Now that the code is refactored and we have tests in place, we can now much easier add new call on our implementation for sending email to notify the client. I'm going to change test cases and make sure that the call to our email provider is done. I will get back to you right after I'm done with it, because I'm going to fast forward that part as well. Now all tests are green again. Now when it succeeds, I'll make sure that I send an email to our client. The values are ignored since they are hard-coded within the method, so I just done it just to show you how I plan the test around legacy code. If we look at the method here, soon as I save the information to database, I send an email to our client. There is one interface called iHTTP client that I have just created, and it is implemented by email HTTP client. It doesn't contain any implementation, and I just want to show you the way or the actions that I take when I work with legacy code. This is what I have planned for this video. I hope that you enjoyed it. Leave a comment below if you think that I've done a good job, or if you have any suggestion. And don't forget to subscribe. Have a nice day.